Hello, everybody, and welcome back to Unit 1 of our Regents chemistry course, which is Math of Chemistry. Today, we will be talking about scientific notations. So, before we jump right into the scientific notation, just to get you guys started on that, uh, have you guys ever heard of the two different types of data that we can collect? I'm sure all of you know what are the two different types of measurements that we can make, or two different types of data that we can collect. So, let's see if these names look familiar. We can either have the qualitative data or we can have the quantitative data. The only thing that makes both of them different is that one of them have numbers, others don't. So the first one is the qualitative measurements, just like the quality of something. Now the quality doesn't have anything to do with the numbers. So these type of measurements are non-numerical. For example, this thing, when I say this thing is very long, that's a quality. It's yellow, that's a quality. This thing is very heavy, that's a quality. So these are all the qualitative measurements. And then we can have the actually quantitative measurements where we do record the numbers. For example, when I say that this person is 6 feet tall, that's a qualitative measurement. I mean quantitative measurement because I'm recording the actual quantity. If I say that the mass of this thing is 50 grams, then that is the quantity of the mass. So that's a quantitative measurement. And make sure and remember that quantitative measurements, where we are recording the numbers, they always have units with them. If you don't put the units, you lose points. So make sure that you guys do not ever forget the units, because let's let's just think about it. If I just say this thing is 6 tall, 6 what? We don't know 6 what. 6 can be inches, 6 can be meters, 6 can be centimeters, 6 can be kilometers. So I have to put the exact unit to tell what do I want to say. Okay? So let's quickly look at some of the measurements and see if we can identify them as either qualitative or quantitative. So the first one that we have is 3 meters. Now we see a number there and we see a unit there. So that is a quantitative measurement. Then we have brown basketballs. That's just a that's just a quality of something. We don't see any number, we don't see any units. So that is a qualitative measurement. Next up, we see 6 kilograms. Once again, we have a number and we have a unit. So that is a quantitative measurement. Then we have several bags. So several it does kind of identify or kind of signal towards a number, but it's not giving us the exact number. So we don't know how many. And we also don't see any unit for that. So this one is also going to be a qualitative measurement because we don't have the exact number. And then 98 degrees Celsius, we have a number and we have a unit. So that is also going to be a quantitative measurement. So make sure that you guys are well familiar with this. Now, what happens in science is that when scientists collect data, sometimes their numbers can be very large, something that can look like this, or it can be very small, something that can look like this. So there has to be, scientists just figured that, there has to be a way to write these huge numbers or teeny tiny numbers into like a simpler form. And that simpler form in science is called the scientific notation or the exponential form. So based on the scientific notation for the first number would be this, and the scientific notation for the second number would be this. Now, if you guys notice, there's like a specific pattern that we are following to write this scientific notation, and this is what that general pattern looks like. So basically we have this number in the beginning, which is multiplying with the power of 10, and that number is called our coefficient. And this number changes. This number basically just comes from the big large number that we are given, or the smaller number that we are given. And then we have got the small power of 10, which we call the exponent. And we'll talk in just a bit of what that exponent means and how we come up with that. And then finally, we have this base of 10, which always remain 10. So that is one thing that remains constant, never changes. So let's quickly look at some of the rules that we follow when we have to write a number in a scientific notation form or in an exponential form. So the first thing that we want to know is that the exponent always represents how many places are we moving the decimal. Okay, now if you're moving the decimal 6 times, exponent will be 6. If you're moving it 3 times, exponent will be 3. But it's not that simple. It gets a bit more complicated because first of all, how do we know how many times do we want to move the decimal? That's the first thing, that first question that we want to ask. So we want to make sure when we are moving the decimal that we land our decimal after one non-zero digit. So non-zero digit is basically any digit out there, like 1 to 9, which is not 0. So we want to make sure that we have our decimal after one non-zero digit. So for example, if you look at this example right here, we would want our decimal to be right after the 6, because 6 is the first non-zero digit. So in a number like this where we don't see any decimal in the question, then in that case, the decimal is normally at the very end of the number. So we would want to move our decimal all the way from there so to right after 6. Okay, so let's see how many times do we move that. So we are moving our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We are moving our decimal 20 times to the left. Okay, so now that tells us that when we put our number now just becomes 6.02. We can get rid of the rest of the zeros. If we don't have any non-zero digit after that, we don't need to report all of those zeros because we are going to put them in the power of 10. So we'll have 6.02 times 10. Now we still have to figure out the power because yes, we know we moved the decimal 20 times, but depending on in which direction are we moving our decimal, whether we are moving that in the left direction or in the right direction, our power is going to be either positive or negative. So a very simple way that you guys should copy somewhere and memorize, make sure that you guys memorize this, is if we are moving the decimal to the right, our exponent is going to decrease. Which in this case, because our exponent is basically nothing, we're starting from 0. So that means if you're moving the decimal to the right hand side, then the exponent is going to be negative. But if we are moving our decimal to the left-hand side, which we are doing in this case, then the exponent is going to increase, which means in this question, when we start from 0, that exponent is going to be a positive number. Okay, so once again, right side, negative number, negative exponent, and then left side, positive exponent. So in this case, because we are moving it to the left, our exponent is going to be positive 20. Okay, now let's practice these rules for the other example that we just saw. So once again, our exponent is number of decimal places that we move. We want our decimal to be right after the first non-zero digit. So this is the number that we were looking at. This we have our decimal, as you guys can see, right after the first 0, and we want to bring that right after that 1 because that 1 is the first non-zero digit that we see there. So let's move the decimal and let's see how many times do we have to move it. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we are moving our decimal 13 times to the right. Once again, now we know that our number is 1.09, but we have to figure out the power of 10. It is 13, but is it positive 13 or is it negative 13? Remember the rule. If we move the decimal to the right, exponent is going to decrease, which means it will be negative. And if the decimal is moving to the left side, exponent is going to increase. So in this case, as we start from 0, that would be positive. So because we are moving the decimal 13 times to the right, in this case, our exponent is going to be negative 13. Okay, so let's look at some of the other examples. Here we have another question. We see the decimal right after the first 0. We want to bring that to after the first 3. So here, let's move the decimal 1, 2, 3, 4 times. We are moving it 4 times to the right. Okay, our number becomes 3.40 times 10 to the power of, is it positive 4 or is it negative 4? Remember our rules. We are moving it to the right, which means exponent is going to be decreasing, or decreasing from 0, so it would be negative. So our answer is going to be 3.40 times 10 to the power of negative 4. Let's do that with this example. So right now we want our decimal to be right after this first 2. And because we don't see it anywhere in the number, which means it is all the way at the end. So let's move it to bring it after the 2. So that would be 1, 2, 3, 4, 5 times to the left. So our number is now going to be 2.4 times 10 to the power of, is it positive 5 or is it negative 5? Remember our rule, if it's going towards the right, exponent is going to decrease from 0 in this case only. So that would be negative. And then if it's moving towards the left, exponent is going to increase. So that would be a positive number. So now we know our answer will be 2.4 times 10 to the power of positive 5. Okay, now let's say you are given an opposite type of question. So now you're given a scientific form and you have to convert that to the regular or decimal form. What do you do in that case? Well, you basically just reverse the process. So you have to move your decimal right or left depending on like however number of times your exponent is saying. But you have to make sure that after you move the decimal, you will have to add zeros to fill in those spaces where you have moved your decimal. And I'll show you guys in just a second what that means. Just remember that if you have a positive exponent, you'll have to move the decimal to the right. And if you have a negative exponent, you'll have to move the decimal to the left to bring it to the original number. Okay? So make sure you guys remember that. Now here we have an example, 3 times 10 to the power of 4. Well, we start with 3, and because we have a positive 4 exponent, that means we have to move our decimal 4 times to the right. So this is where the decimal is right now. We'll move that 1, 2, 3, 4 times to the right. Now, as you guys see here, this is where our new decimal is going to be. But what do you do with all these empty spaces in the middle? We can't just leave them blank. So we have to add zeros there. So overall, our answer becomes 30,000. Okay, let's try it with this example. This time we have 2.1 and we have a negative 3 exponent. So when we start with 2.1, we move our decimal 3 times to the left because it's a negative exponent and it's a negative 3, so we know we have to move it 3 times. Now once again, that's where we have our new decimal, and we will have to add the zeros in between to make it a reasonable number. So the answer is going to be 0.0021. So that was the first part of the scientific notation class, and in the next video we will be talking about how we can perform different calculations, addition, subtraction, multiplication, division kind of thing with using the scientific notations. Alrighty, happy learning. I will see you guys in the next one.